Okay, so welcome to a discussion on WebSockets. This is a fun one. So the most obvious question we're going to ask ourselves is what is WebSockets? Is that bad grammar, by the way? Should it be what are WebSockets? I'm not sure. Let's take a look. What are? But WebSockets is a thing. It's actually a concept. So who votes is, who votes are? I think it should be is, even though it looks kind of weird. What is WebSockets? It's a concept. And it's a proper name. I guess it's an is. Yeah, good point. If it's a proper name, it's an is. Just looks weird. What is WebSockets like? Yeah, really? Okay. Anyway, so what is WebSockets, and how do they work, and what do we use them for, and why do we have them at all? Um, and well, WebSockets are sockets. They're just like the sockets you used in week 2 with the snake game, which was a local version of sockets. So we're using a web version of the same thing, and they look pretty much the same. So a lot of what we'll be doing here today, you're going to think, wow, that looks almost exactly like the stuff I did in my snake game, just we're doing it in the web instead. And we'll talk a bit about client server. We'll build ourselves an Express server with an HTML client, because there's always a client and server. We'll build a client that talks to a server. We'll build the beginnings of a little chat, a web chat app. With a connecting, we listen for events, and we'll talk about custom events. And about the last half hour, we're going to take our simple app and turn it into a React web chat. Because really, we're going to be doing stuff in HTML jQuery to start with. The conversion to React is almost trivial. So I'm not going to be doing React to start with because it's not necessary. We're dealing with the concepts of events. But the last half hour, we'll maybe start building ourselves out a React version of this same app. All right. So WebSockets is always a client and server. Now, in fact, I built a little project here with my client and server. And this is important to remember in any project you work on. Make sure you understand that there is a client, React, jQuery, whatever that is, and there is a server. And they are completely separate programs, completely separate. Sometimes the temptation is to mix the two up. I know in week 3 we did our tiny app, and that is a server only app, and the server is sending us HTML all the time. So there is no real client app, it's just static HTML. And we got a tweeter, and that one had a client and server, although it was one program. The server would send us HTML, and then the app would run on the client. And then, of course, into React, where there really is just the client app, and the only thing we use our Webpack server for is just to send us the JavaScript, and that's it. But in production, there will be no Webpack. There's just a browser app that is sent to the browser by some server, and it could be anything like Apache, Nginx, or anything. So in this case, we have an Express server, just because it's a nice, convenient server, and we have a React app, which we'll work on later. In my Express server, right now, I have a server.js. I have the world's simplest server.js. This is really the bare minimum you need to fire up an Express server and make it work. Let's start this thing. npm start. Okay, so now my server is running on port 8081. It's an Express server, and if I go to port 8081 on my browser, let's grab a browser here. Here we go. Go to 8081. I should expect to see cannot get slash, which is exactly correct because I have an Express server that is doing absolutely nothing. It is just starting and not sending out any routes. There's no app used. There's no app getter post. So I expect this. So what I want to do is I want to turn this Express server into a WebSocket server. And that is actually really simple to do. Once again, we have our client and our server. And our server, generally HTTP servers are request response, aren't they? If I had an app.get, that would send a request to my Express server here, and the Express server would send a response back. And that's the traditional HTTP protocol. But WebSockets takes advantage of an interesting concept of the HTTP protocol, because nowhere in that protocol does it say that the connection has to end after the response takes place. It doesn't say that. It just says send a response. It doesn't say send a response and that's it. It only says send a response. And then the connection remains open, and that can be used for WebSockets. And let's look, I've got a little image here that demonstrates the actual process for a WebSocket. There. So we have our client and a server. A WebSocket connection starts off just like a regular request response. The client sends a request. It says, hey, I want to start doing WebSocket stuff. I want to essentially upgrade my connection. The server, if it is so configured, can go, great, yes, I can do that. Here, we're good. So the server upgrades the connection to the client, sends a response back. So right now it's still a response going back to the client. And now the connection is upgraded, which means binary information be sent back and forth by either the client or the server whenever they feel like it. There's no more request response. It's just send and listen to events back and forth. This is the foundation of pretty much every web chat, video, game, anything out there. And as we know, these things are fun. Anybody played this game? Oh, look at that. Ah, I died. Yeah, so this is WebSockets. If you take a look here, so there's a WebSocket connection, right, that is started. WebSocket connections don't log because there's just so many. There'd be thousands, but it does log the fact that I requested a WebSocket connection to this particular snake, and I'm dead. Okay, so that's how they work. So all the games, all the videos, all the chats, pretty much everything that you use online that's fun is WebSockets. And it takes advantage of the fact that you can do a request response, but the server and client leave the connection open, and it's what's called an upgraded WebSocket connection to allow for bidirectional messages back and forth, just as if we're connected by a network cable using sockets like in week 2 with snakes. It's really fun. And well, is this stuff kind of hard to program? Well, actually, this stuff is fairly easy to program. It's not much more difficult than the stuff we used in our snakes program in week 2. We do a connection, we listen for data, we can send things to our socket, and that's kind of it. So let's just go ahead and let's upgrade this particular server so we can make it do WebSockets. Now we're going to use a library called Socket.io. It's pretty popular. It's probably the most popular library out there. Let's take a look at it. So Socket.io. There we go. So very, very well documented. Yes, I know there are Socket.io haters out there that say, don't use Socket.io. Oh my God, it's so terrible. No, it's not. It's been around for a long time. It's very reliable. And it gives you extra features that standard sockets don't use. So Socket.io is widely used everywhere, and it's a great library. And it makes it easy to use because it looks just like jQuery. So it's a great library, and we'll use it today because it does help us abstract quite a few things away. And it's pretty fast. It's not a bad socket library. And getting started. So this is not like any Cypress documentation, but it's still not bad. All we have to do to start using Socket.io is to include it in our HTML. By the way, this is a very simple file. I have one HTML and I've got one script. There's my script. It's an empty document.ready. There is my HTML, which is pretty simple, and I am simply importing or including the Socket.io library and I'm including jQuery just for fun. So all you'd have to do is simply include that in your jQuery. We'd import it if we're using it in React, and we'll look at that later. We include this library in our index.html, and that's it. And I've got my index.js, which, as you can tell, is pretty much a page that does nothing right now. Okay, so let's take a look. What we should do for this, what I wanted to begin with this server, I want to make my Express server actually send out my index, because when I do get slash, it says cannot get slash, but my index HTML is right there. So what's wrong with my Express server so far? Here's my Express server. Why is it not sending out my index.html, even though I've clearly got one? But when I say go to the 8080, I get cannot get slash. Any ideas why this is not working? Why am I getting nothing? There's no routes. I've got nothing, do I? I have no routes. But if I was to make a route, app dot get like that, and there, and request response there. Well, now I have a route, and I could do res.send hello, and that would probably work. Oh, you're right, get, there we go. Well, now it says hello, which is better, but what I really want, I want to send out my index.html. I don't want to have to type the whole thing. I mean, I could do this, I suppose, and paste this whole thing inside here. That'd be ugly. I could do it. I don't want to. That might work. Let's take a look. Well, that does work. Let's go view source, and well, that did work. Okay, but that's really ugly, isn't it? So there's got to be a better way to serve out my index.html rather than just doing this, because that is pretty ugly. Well, it turns out there is, and it's very commonly used. What we do is we simply tell Express to identify files to just send out. If you get a route for something and it's not one of yours, just send this file. And we do that using the static method. So be app.use, and it's going to be express.static. Static. And we say, and the default is use quote. You can take two arguments if you want. In this case, it says if you receive anything for slash, so anything for slash that is not identified here, use this and look for them in the public folder. There. There. And there's my public right there. My public contains some scripts, and a bunch of other stuff. So pretty much everything, a favorite icon, all the cool stuff. So now I'm telling Express that app.use. Oh, VS Code's aggressive these days. Express static. That means that when you see slash something or just slash, look here for it. So if you see slash scripts, if you see slash styles, and it's not one of your routes, go look there for it. And that in fact worked. So now it is, if I refresh again, it's loading my HTML or my index HTML along with any styles. I happen to have a little bit of style here. So I've got a slightly gray background, I think a slightly different color. So I'm also getting my styles as well. And I'm probably getting jQuery, which we'll find out in a second. So that's how we make Express load files, is to say static, which means anything that's not a route and looks for slash, it'll load it right here. Okay, so let's go ahead and make our app, or Express app, respond to WebSockets. So how do we do that? Really simple. All I want to do right now is take advantage of the fact that app.listen returns something. It actually returns an HTTP server. So const HTTP, or server if you want, which is just a lower level server that Express is built on. And then I can use that. I can use that to initialize my WebSockets with. And I'm going to build another file because it'll make it easier. I could do it in here, but let's make it in a separate file for now. Let's build ourselves a little file. We'll call it our socket server.js. I could put all the code in my server.js, but I kind of want to keep it clean because maybe I have other stuff. Maybe I have actual request responses. Remember, this server does not have to be dedicated to WebSockets. It can do regular stuff, routes, Postgres, all kinds of stuff. So I may have app use, some routes, or all my other stuff. So I'm just going to kind of tack on WebSockets as kind of an afterthought into my server.js. So there. So I'm going to two things. I'm going to require the socket IO library. That's the main thing I want to do, is require my socket IO. And I make sure I have to install this thing. Let's take a look. It's probably not going to be there. So let's go install. There. So npm install socket .io. There we go. Pretty fast. Okay. There it is. Socket IO is now installed. I can now use it. Okay, we're good. Okay, no change so far. Let's go ahead and simply, in our server.js, we're going to require our new socket server. So we'll say a socket server equals, and we're going to require our new socket server. There we go. Okay, and it'll like, great. So it looks good. It's all happy. Okay. And now all we have to do is simply listen for WebSocket events. So what we do in our socket server, it's really just a one-liner. We simply say, I'm going to make a function called listen first off. Oops, const. And pass our HTTP server to it. Once again, I'm just putting these in a separate function to make it clean. I could have put this all online inside my server.js. So there's really only one thing we have to do, and that's this. I'm going to say const server equals, and it's really simple. We say socket IO, and we give it our server. There. And that's it. This thing is now WebSocket enabled. It is now listening for WebSockets, and it will accept WebSocket connections. So it's great. All I have to do now is return my server in case I want to. Don't need to, but let's just return the server for now. And we're going to export our equals our little listen function. Okay, so there's our listen function. That's optional, but all it's doing, we're telling it to just start listening. And now we have our server. At the very end, when all is finished, our server will simply go ahead and just enable WebSockets. At the very end of this, after all the Express stuff, right at the very bottom, we can say socket server dot listen with our there. So that's all we had to do. In our Express server.js, we just added a one line at the bottom saying do some WebSocket stuff. And what that does, it puts everything else WebSocket related inside a separate file. That's the only reason I did this. I could have had everything inside my server.js, but it gets a bit messy, so I put everything inside here. I call this function listen, which just enables WebSockets. Okay. So now my socket server is listening for connections. So how do I connect to a WebSocket server from the client side? Right now, this is on the client. This server, this Express server, is now listening for WebSocket connections. So now I need to my browser, in this case it's a jQuery app, but it could be anything, to now connect to its WebSocket server. And of course, that's now done on the index.html and index.js side. So now I'm on the client side. With WebSockets, you kind of have to wear two hats. You work on the server side, do some stuff, then stop. Then you go to the client side, the browser side, and make sure that what you're doing matches what you just did on the server. So now I've had the server listen for connections. I'm going to go to the browser and have it now try to make a connection with that server. Okay, let's give that a try. So pretty simple. I've already included in my index.html this, so it's relatively simple. All I need to do a connection, and it's really, really simple, is just inside your JavaScript somewhere, you can just say const socket equals, and it's called IO. It's the IO function. There. And what that does, that makes a connection to the server. Now, the IO function does take parameters. I could say some other server, HTTP or S : someplace else. But if you just want to connect to your server, and your server is defined as the server that sent you, or in this case, the server that sent that index.js. So if this page came from localhost 8081, then IO with no parameters will try to connect back to that same server. It's not required. You could have it connect someplace else, but you got to be careful because you could have CORS problems, right? It might refuse to have connections not from its own domain. So IO with no parameters simply says connect back to whoever sent me. Just sends a connection right back to the same domain. And that's it. So now we have a connection. Let's take a look. In fact, let's even see if we open our dev tools, we're going to get something. Let's take a look if I can see in my network tab my connection. There. Look at that. It did send out and got a response, status 101, which tells me I got an upgraded connection. A WebSocket connection has been established. Of course, nothing on the screen, nothing on the server because I haven't done anything else. But according to this, I have made a really great WebSocket connection to my server. Okay. Well, now what? Well, why don't I go back to my server and say, well, when you get a connection, maybe just print something else. Hey, somebody connected to us. We got someone connecting. So back to our server. So now I've got my socket server and I've got my listen. So really, I'm going to do everything. This is just setting up the connection. So really, everything's going to be done inside my listen function now. So I'm listening. So once I'm listening, I'm going to say, well, how about if I get a connection? What if somebody connects to me? So I'll say server dot on. This is an event. Haven't seen these before, have we? How about on connect? This looks an awful lot like jQuery, doesn't it? So on a connect function, on a connect event, I will execute something. There. I will do something if I get a connection. If I get a connection event, which means somebody connects to me, I can do something. And in this case, I'll just console log connected. There. So someone connected. This is an awful lot like the way jQuery works and the way our original sockets worked as well. It's something on connection. This is why we tried to encourage people in jQuery to use the on, so on click, on submit, as opposed to the dot click and the dot submit jQuery functions, because it gets you more used to the more modern syntax, which is server dot on and then connection. So in this case, on a connection, I'm going to print somebody connected. Okay. Oh, look at that. It's already there. That's amazing. One thing about Socket.io, it is persistent. It is a persistent little thing. It will make sure that your connections are always there. Like if I browse away and browse back, it connects again. It's like nothing. It just does it right away. If I stop the server and start it again, and stop my server and start it again, connect it again. I'll tell you, it's persistent on your browser. It will kill itself trying to keep that connection going. So it's a really robust connection with Socket.io. You can pretty much be guaranteed the socket is there. It's a different socket, but no matter what happens, there's going to be a connection. If you said to start one and you didn't kill it, it's going to be there. Okay, so connected. So somebody connected. All right. Now the cool thing is, with my connection there, so my connection event, every client that connects to me runs this. So essentially, you can treat this as a per client block of code. So for every client that comes in, they're going to run this block of code. In fact, we even get as a parameter a client socket. So you can call it socket. I oftentimes call it client to keep it straight in my head. You get a client socket or client parameter, which tell you which client connected, and that client object has a lot of stuff inside it. Let's take a look at it. Ooh. Let's just take a look. There. We've done this before, haven't we? You get a lot of stuff. Look at this stuff. That's even bigger than Axis Res, isn't it? Wow. It's enormous. So as you can tell, a lot of stuff inside a client socket. The thing we're most interested in is the client or the socket ID. There, that's the important thing. The socket ID or the identifier of that socket. There. That is the actual useful identifiable thing for this particular connection. Thank goodness, because you wouldn't be having that whole client object. But that is a unique string that uniquely identifies the particular browser that is connected to your server. And it is totally random and it's ephemeral, which means it might change. So if I browse away and browse back in again, they connected again, different socket ID. So very important to remember, these socket IDs, these client IDs, they can change on a moment's notice. So you would never, ever write these to a database, ever. They'd be kept in memory someplace and maybe a table, which we'll do later, but these are not persistent IDs. So if I refresh the page, it gets a new one. Refresh the page again, totally random and totally ephemeral, which means they can change anytime. Really, the person refreshes or browses away, they'll reconnect and get a new one. Okay, but they're guaranteed to be unique among all connected clients, which is great. And that's a pretty big number. What is that in decimal? It's a pretty big number, probably more than all the computers in the world combined, I think. So you can have a lot of clients connecting to your server. All right. Well, this is great. So now I'm identifying when I have a client connected. So now let's identify on the client side when we connected to our server. So now I'm going to switch hats again. I'm going to go back to my browser. So when my socket connects, there's also things I can do on my side. I can also do things like listen for events, such as the connection event. So in this case, I'd go probably socket on. Once again, on. In this case, it is called connect, not connection. So when you get a connect event, same thing. You can then do stuff and run a function. There. And I'm just going to log connected or connect to server. Okay. All right. Okay, let's go to our console log. Okay, let's refresh our page. Okay, so now we know on both ends we got a connect to server on the browser side. And on the server side, we got a connection. So we do have synchronization that way. We know that somebody connected and we connect to them. So that's really connect. Now, normally we wouldn't, unless it's maybe a game of some sort, we wouldn't automatically connect whenever the page is started. All that can happen sometimes. If the page is simply does nothing but WebSockets, then like a game, it would probably do a WebSocket connection immediately. But in some cases, you want to maybe do something before that. Maybe the user logs in, gets his user ID, his name, and you want to, have some information about the user first, and then make your WebSocket connection. In this case, I'm going to write a web chat app, so I really want to know who is connected first before I do anything. So I'm going to assume that there's a login process, maybe a request response, but at some point, we're going to have them connect to the server after the page starts. So let's make ourselves a little function here instead. So I'm going to make myself a function. I'm going to say const connect. So now it'll be an action that's initiated by the user instead of just happening when the page loads instead. So there. Okay, and instead of doing this, it's going to do the socket IO here instead. So let's do this. There. So now, okay, great. So now instead of running on startup, this will be triggered by some event from the user instead. And the obvious event is probably going to be a button, isn't it? So we probably need to give ourselves some kind of button that will allow us to connect to our server. So let's go ahead and make a button. There we go. Okay, and we'll say connect. Okay, and we'll give it, I know it's not a good idea, but I'll call it ID equals connect. There. Okay, there's my connect. I've got a button that says connect, and okay, great. So now I've got a button. Of course, in jQuery, I can add any kind of listener to that button. So let's go ahead on our browser, and we'll go ahead and add ourselves a listener to that button, which is pretty simple. We simply make a dollar connect, don't we? Dollar. It'll be a pound connect. This has been a while, hasn't it? Like week 4 doing jQuery. Like it's pound, right, for IDs? Yeah, it is. Okay. And it'll be on. Click. Notice the pattern. This looks a lot like WebSockets. Looks a lot like jQuery, doesn't it? So on click, and we're going to call a function. There. Great. And we'll just do our connect. For now. Okay. I think my VS Code's getting more aggressive. Anyone notice that? It is starting to type a lot more stuff I didn't type before. So, okay. So now when I refresh my page, I should get nothing now. Let's take a look. So nothing yet. Hopefully, if I click connect, connected. Great. That's great. Okay. Click it again. Connected. Okay. I've actually got 3 connections now. Not a good idea. So I probably should stop. So very likely I should find a way to disconnect my server as well before connecting again, because this could get you into trouble with doing multiple connects to the same server. You really could have an issue. So I probably should make myself a button to disconnect from my server. Simple matter. Make a button with an ID of disconnect, and I'll call it the original disconnect. Okay, great. And now I need to somehow disconnect my button, or disconnect my socket with my disconnect button. So pound disconnect, there, on click. Okay, and there is a function called disconnect that is built into a socket. So I can go socket.disconnect. So I got socket.disconnect. But I have a problem, don't I? So what is my problem? This is very similar to our snake game. We have our connection here, we need it. This is really our con, isn't it? Our connection. But it doesn't exist. It's not in scope here, is it? So I need to find a way to get this connection into here someplace. And much like we did in the snake game, I'll just go ahead and make myself a variable. Let socket. I'll make it null to start with, just to be nice. There. And I can have my connect function return the socket. So there's my connect function, and it's going to return the socket. So now my function, my connect, when the user clicks connect, it will do the connection, return the connection back up to my code here, which will allow me to use that in subsequent listeners like disconnect. Okay, so I'll say socket equals there. And now I can use this socket in here and disconnect. Let's give it a try. So let's look at our server. With these, you kind of have to have 3 windows going at the same time. So I'm going to connect and disconnect, connect, disconnect. Great, that's fine. It doesn't tell me it disconnected though. I should probably go to my server and maybe I should listen for another event. So WebSocket development or coding is all about events. There's the built-in events, connect and disconnect, and you make your own events as well. So right now we're talking with the 2 of the primary events that are built in, which is connect and disconnect. So in our socket server, all we'll do is we're going to simply add listener. And once again, everything takes place inside here now. This is for each client. So I need a listener. Server.on. Can anybody take a guess as to what the event might be called if a client disconnects? What would that be called, do we think? Any guesses? What the event might be called? Disconnection? Yes, could be that, but it's a little bit shorter than that. Disconnect? Yes, it's disconnect. Disconnect. If someone disconnects, run some more code. So do this if the client disconnects. And we're going to, this console log. And we'll say disconnect. Now I'll also print out the client ID. Because once again, we are within this block here. And client exists for the entire block. That's why we put all of our listeners inside this block of code. Because once a connection happens, everything else happens here. We have this client. We can always refer to the client all the way down. Okay, so now we've got both ends. Let's take a look. Hopefully we should be able to do a connect. And where's our server? Disconnect. So now we connect. and disconnect. The question is, should something be added to the connect logic to prevent users from making, Julia, yes, awesome, awesome point. You're ahead of me. Yes. Now, of course, we can disconnect. Disconnect twice, that could be bad because it might even crash my server. So you're right. Not a bad idea to check if they're already logged in. So maybe I should add some logic, shouldn't I, into my client side and not connect if they're already connected. And probably a good place to put it would be right there. If socket. I want to go if not socket. I'll do my connection, do that. Or if I could maybe say if socket, do a return. I think I'll do it this way because maybe I want to do more stuff inside this function a bit later. Okay, so now if there is a socket, then I'll connect. If not, I won't connect more than once. Let's try it again. So now, let's see, we should only connect once. And great, we're only connecting once. We disconnect. Okay, we probably might want to make sure we don't disconnect a null socket as well. So maybe we should also only run the disconnect on our browser if we actually have a socket. So what I'll probably do is I'm going to make myself maybe a little function. I'll do it in one line. Let's say socket equals null. Otherwise, we can't connect anymore. So now we make it free. We can open the socket again. Because before we couldn't do that. We couldn't connect again if we disconnected once. We disconnected only once, we can connect again. So we can't do anything right now. We're frozen because the socket variable still had stuff in it. So now we're going to clear that variable. So now this now works. This code will now work, which means socket is null, which means we can connect again. Okay. And one more piece of logic will go if not socket. We'll return. We don't want to disconnect if we haven't got a socket, because probably doing something on null will have bad results. Okay, let's give it a try. Connect only works once, disconnect, and we can connect again. Look at that. Connect, disconnect, and each time we get a different random client ID. I love it. Okay, so this is great. So right now we have the foundation of a WebSocket application with connects and disconnects, everything synchronized. Now we need to do something. Now we're going to make a chat app. So really all you need to send a message to anybody else on the system is their socket ID. Let's simulate this. Let's make another browser. Let's make ourselves another browser here. There, get out of there. Oops. There, now we have two. I'll take it out. There we go, got two of them. Okay, so now I have two of these clients. There, and this one's connected, and now I have two connected at the same time. This is great. So I'm going to have the server start sending messages to these clients. So disconnect, disconnect. So let's talk about how to notify a client that something has happened. Right now, the server is simply sending, connect events to the browser. Let's send some other kind of events to our server. So what we'll do is on our server side, we're actually going to send something when the browser connects. We're going to say, you've connected. In fact, we'll tell everyone that someone has connected. How's that? So what we'll do is, why don't we say, we're going to say, now in this case, it's called an emit function. It's called emit, like this. And you can go server.emit. server dot emit. There, we're going to emit something to everyone on the system. And this is what's called a broadcast message. And you'll see this. I think, has anybody done the scheduler app where we did the WebSockets part? Anyone give that a try? Anyone try the yeah? Was it kind of fun, kind of weird, a little unusual? So yeah, it was interesting, wasn't it? Yeah, it was pretty cool. That was, in that case, it was just a simple emit. We weren't doing anything sophisticated, really. It was just a really simple capturing. In this case, when an update's made, the scheduler server does some stuff, but it also does an emit to every browser connected, and it sends a little object which tells it that someone has added or removed an appointment. So we're going to emit. So this is all that's needed. I'm going to send just something to every single client, and I can send just hello. Now with emit, you can do two things. You can send a generic message, but the really cool thing about Socket.io is you can send custom events. What's an event? It's an on thing. You can make up your own words, so on anything you want. So I can make up my own name for an event. I'll call it, what should I call it? Notify. I'll call it notify. I'm going to notify people that something has happened. I'm going to say connected, and let's see, like this I'll say, and I'll send the actual, there. I'm going to send the client ID. There. Okay. I'm going to tell everyone that this person has connected. Not normally something I do, but I'm going to say this person is connected. I'm going to send to everyone out there that someone has connected. All right. So let's do that. Now, and so now we have to have our browser be able to listen for these events. So now the server is emitting a broadcast message, and we'll talk about why that's different from a point-to-point message. This is a broadcast message to everyone. It's emitting a notify event. So now I can go on my index.js and do something with that. So I can go ahead and listen for events. And what event should I listen to? It's going to be an on, isn't it? So what event do you think I want to listen to in my on notify? Exactly. I'm going to listen for an on notify. So I got my on connect. Let's listen for socket.on. Let's listen for a notify. Notify. And then we'll do something. We'll probably get some data back. So we'll just say data, a lot like the snake game again. I could have called it data, but I call it notify now. I'm going to just console log. Let's just log that data. There. So now let's turn on our DevTools. And now, make sure, hold on notify, socket, on notify. Let's make sure. Take a look, make sure we got her going here. And now we got to connect. There we go. And look at that. So now I received a message. Let's open up another browser and see if that person gets notified that someone else logged in. This is where it gets cool. So here we go. All right. Now let's open up this dev tool. Okay, now we're going to connect this one and they both get notified. So you must be connected to get notifications, obviously. Okay, well, this is really cool. So why don't we simply, instead of doing it in our in our DevTools console. Let's go ahead and put something on our screen because it gets kind of awkward otherwise. So I'm going to put little notification. I'm just going to paste one in here really fast. Put something here. There. I'm going to put a div at the bottom of my screen just to list any notifications I got back from my server. And then on my onNotify, all I'm going to do is, there it is right there. Instead of console log, I'm going to simply grab my little notify thing. I had a class of .notify. Let's double check. Yep, .notify. I'm going to say .notify, and I'm going to just make its content HTML. It's HTML equal to the data that I got. There we go. And we got a connected and disconnected. Great. So now we're now rendering on the screen that someone's connected. Let's go to our other browser. Refresh that page. There. We'll do a connect. And look, they both got notified. So if I disconnect this one and connect it again, they both got notified that somebody was connected. So this is great. I now have a custom event that I can send to all of my browsers. But really, I don't want to send this particular event to everyone because really I just want to tell the person that connected, just send to them that you have connected and here's your socket ID. Although this is useful information, I wouldn't be sending these socket IDs to everyone because somebody's can change. We talked about that earlier. These IDs are ephemeral. They can change in a moment's notice. So giving them to every single browser wouldn't be very counterproductive because if one changes and somebody relies on that to send somebody a message, then it could have changed. They'd never get their message. So probably I'm not going to do that. I'm going to have instead, I'm just going to tell the person that connected that they connected. So instead of an emit, it's back to my server. So this is a broadcast message. Event. Let's send ourselves instead, let's send a client message or a single message. So what we're going to send just to the particular client that we want to send it to. And we use emit. It looks almost the same. There's one minor difference when you want to send to a particular person or a particular browser. So it's still server dot, but instead of dot emit, what you want to do first off is just say to and then dot emit. And everything else is the same there. It's server to, and guess what goes in the to? Guess what goes in the to? It's the client ID. To client ID. So now we're sending a message just to this client ID. So there is really the two forms of emit, broadcast and point to point. And really that's like everything you need to know about WebSocket socket right there. We've pretty much covered it all in the first hour. So let's just comment this one out and we'll see if this works. So now we're just sending to the one client that they have connected. So refresh this page, and now we're just sending to one client that they have connected and one client that's connected. This is great. Now, you may ask yourselves, why am I not sending anything on disconnect? Do you think I should be able to send something here when I disconnect? Of course, the answer is no, because they disconnected. So I can't send them anything after they've disconnected. So I wouldn't be able to send them a "you have disconnected" message. Unfortunately, it wouldn't make any sense, right? So because they're being long gone. So this pretty much is WebSockets right here. You can respond to events. So you can say on something. And by the way, this can be anything. It can be a string or an object. We'll do objects in a second. You can listen for events, and you can send custom events to one or all of the connected browsers. And you can call those events anything you want. This name is completely up to you. By the way, fun fact, if you omit this one, or omit, if you omit the custom name in an emit, you get the type message. That's it. It's just quote message. It'd be the same as if you'd said message. I discovered that myself. But almost always you give it some kind of custom name. It's just easier for you because then you can track it on the receiving side and you can make them listen for different messages. This is what makes Socket.io much more powerful than plain WebSockets because you can identify events by name instead of just getting a random or a generic message and then having to parse the contents. You can send it named messages with custom names and only listen for those particular things. And you know what they are when you get them. So I know this is a notify, which means I know to put this data in my notify block in my web page. Okay, so that in a nutshell, in a socket, is WebSockets with Socket.io. We can make connections. That's pretty easy. Equals IO. We can listen for connections on the server. That's just on connection and do stuff. We can listen for disconnections and we can disconnect. Simple. And of course, then we can send messages to all or many or one client, and we can then listen for those events. It's pretty cool. Okay, so that takes us to our break. Let's break for 10 minutes and we'll build out a little more of this. And if we have time, we're going to go ahead and try to put this inside a React app and see how it looks pretty much exactly the same. There's almost no difference. So, okay, let's come back at the 50, okay? And we'll carry on after that. All right. Hey, everyone. Talk to you in a few minutes. Okay. Another few seconds and we'll carry on. WebSockets are really fun. They really are. One of my favorite things to play with. And because they're so easy, the actual WebSocket side of things is actually really, really easy to play with. So, okay, let's carry on with our talk about WebSockets. Let's get going again. So carrying on, we've covered really all or almost all we need to know to build ourselves a full WebSocket applications. We've really covered all the kind of the theory or the methods that we use to send stuff. So let's talk about how we would do things in a WebSockets application. So for one thing, let's say we're going to notify all users that somebody has connected, or at least there are a number of people connected. So what I want to do, I want to keep track in my server of really who's connected. So let's start. Let's put ourselves a little variable. We'll call it connected. We'll call it let, because we're going to change this. It's going to be let connected equals 0. So now we have a number. We can track how many clients are connected at any particular time. And what I'm going to do now, when I get a connection or a disconnect, why don't I now send to all the clients again just the fact that the number of clients connected has changed. So the first thing we'll do is when we get a connection to start with, we will then just bump our connections. So connected plus plus there. So now we've increased our connected count, and if someone disconnects, we're going to decrease that, which is right here. There. So now we're keeping track of the current number of connected clients to our WebSocket app. And what we'll do is we're going to then send, each time, we're going to send a message to everyone saying, hey, there is now 3 users connected. There's now 10 connected. So, and then we'll be able to see in real time as people connect and disconnect from our game, we can tell everyone, oh, you're player number 15, and there's 120 players connected. This is great. So I'm going to make a little function because I'm going to need this because I'm going to use it twice. So I'm going to make myself a little function, probably just in here someplace. I'll put it inside. Doesn't matter. I can put it outside. Really, it doesn't need to be just inside here someplace. So I'll just put it inside here. There, and we'll call it send status. I'm going to send the status to everyone in my group of connected clients. And really all I want to do is send them a broadcast message. So I can take this, because this is what I used before. There. Let's just send them something. There. And we're going to send them an emit, but it's not going to be a notify, because a notify is for a specific person. I'm going to make myself another custom event because I can, and I'm going to call it status, which is going to go to everyone. There. Sends that. I'm going to send this status event to everyone. And now I don't want to send connected because that's not going to be useful. I'm going to send the actual number of connected clients. So I'll just send there. Okay, so I can send, actually just connected there, like this. Getting ahead of myself. So I'm going to send the number of connected clients to everyone. So now if somebody receives a status message, they're going to get a number in the data. And I can simply use that and I call my set status, which is just really just set status. There's no parameters needed because it just sends to everyone. And set status on connect. So when I disconnect and connect, I now update the number and I tell everyone what the new number is. Let's go to our client side and we'll take advantage of that. So first thing we need is we need a place to put this status. So I'm going to put this in my index.html and make myself a span right here. There we go, and I'll call it the class equals status. Sure. Okay, and it's going to start with 0. So great, I've got a span of status. So needs to be a div. Okay, let's put it in a header, make it look a little nicer. Inside an H4. There. I'll make it look a little nicer too. So okay, that looks nicer. Okay, and I'm going to say, I can just go ahead and say connected clients is there. You get spoiled with React, don't you? With the page refreshing, it's like, why is it not changing? Oh yeah, this is not React. That's right. Okay, so connected clients, great, equals 0 at the current time. So now, still on my client side, when I get an event, and if that event is a status event, well then I know that I'm going to get some, or I can now listen for that, and I can put that number inside my span. Okay, so let's go ahead and do that. Let's go in here, let's listen for socket.on. And I know everyone knows what it's going to be. Socket.on is going to be status, because that's the name I made up. And data, great. And it's going to be almost exactly the same as this, isn't it? But instead of my notify, it's going to be my dot status. So now it's going to be my dot status HTML is going to show this number. Whoops. Do it again. There, that's better. Okay, show the number. So let's refresh the page. And now when I connect, oh, hold on status, notify, oh, status. That's dot status. There we go. So when I get a status message from my server, let's make sure, I'm going to send a status to everyone. I'm going to get a number connected. Let's take a look. There we go. Disconnect, connect, disconnect. So now connect, if I hit this one, they both go to 2. If this one disconnects, oh, let's take a look. Not quite, oh, I'm gonna have to sync up again. And let's take a look here. So there. Are we sending it to everyone? Let's take a look. And let's make sure we're sending to everyone. We got our, let's make sure we refresh everyone again. They should both be sending. Oh, of course, because we're not connected yet, of course. So right now, if that connects, that'll update 2. So you can't receive messages unless you're connected. So disconnect both again, there. So we'll connect this one there, and we'll connect this, and now they both go to 2. So that can be a bit of a gotcha. You cannot receive messages until you're actually connected to your WebSocket server. So great. So when this one connects, it doesn't go down, does it? Because it can no longer receive messages from the WebSocket server. So it didn't receive a status message, but this one was still connected, so it went down again. There we go. But if this one disconnects, now this one drops, and of course this one wasn't notified because it was disconnected. Okay, all right, that's cool. Now let's try, and just one more thing, we'll try and see if we can, what we do if you want to send an actual message to somebody, because right now we just notification server. what happens if one user wants to send a message to another user? Because that really is. Make 3 browsers. Yeah, I could. Yeah, good point. Let's make 3 browsers. I like that. Go ahead. Let's try that. There we go. Okay. So we have this one connected. So now we could 1, 2. Look at that. And they're connecting. Look at that. See? Connect, connect. Yes, great idea. Yes, this stuff is so cool. I love WebSockets. They're so satisfying to play with because you see stuff happening in real time. It's great. Can on this? Yeah, we could. Yeah, when I click on disconnect, I can certainly change the number, and I probably should. But I can't really do it because I won't know what the disconnect is. I suppose I could bump that number down, but it wouldn't mean anything. So it's a bit tricky. I'd probably just maybe just erase that if I wasn't connected at all. You know, it'd be a thing that didn't even exist if you weren't connected, which makes more sense, right? So okay. Yeah, better to hide the span, exactly. Better to hide the span. Say you're not connected, you can't receive information. But this is a pretty cheap app, so we haven't got enough of a budget in our 2 hours to do a lot of these features. Okay, now I want to be able to not only send broadcasts and send messages from only the server to the client. I want to have a client send a message to another client. That's the big one. How do we get one client or one browser to send a message to another browser? Well, we know that each one of these has a unique client ID, don't we? But we also know that we can't send to that from the browser. We cannot let other browsers know about client IDs because they could change at a moment's notice. So they'd be useless. If I sent something to CDR, BB, whatever, and that was disconnected, or there, now it's changed. So if client 2 tries to send to the other one, it's not going to get anywhere. So that totally is not useful. We need something else. So normally, when you've got apps like a web chat app, you've got a person logged in, like Bob or Alice or Kira or something. They have a name or maybe a user ID. Because remember, the WebSocket ID is not the only thing running in your app. You've got your actual Express stuff happening. Maybe a login page. They logged in using a password. Now they're in. You know who they are. Your app, in this case, your index.js, it knows who this user is, don't they? It knows this is Kira, user ID number 12 in your database or something. So you know that. So although the socket ID can change, that user won't change because that is their ID in your database. They are user ID 12, which is great. So that's something you can use as well. But the socket server, it can only send to client IDs, can't it? So we need some way to map users to client IDs. Now, in JavaScript, can we think of any data structure that would allow us to map things using maybe keys, for instance? Yes, of course. Yeah, Alan. Objects, of course. We can make ourselves an object. We can make ourselves a user's object. Const users, there. Oops, object. And we can map names to socket IDs or socket IDs to names. That's a design choice, and we'll discover which way is better in a minute here. But yes, we can certainly go ahead and map users to names. So great. So what's the best way to do this? Should we have our users database look like this? Let's take, for instance, let's see, let's have a sample object here. There. Maybe it'll be Bob and colon and then some random number for our ID. That's one choice. We could do that. And Alice. Oops, and Alice. Or it could be the other way around. We could have like that. Now this is a design decision we have to make. We've got to ask ourselves, well, geez, what's the best way to do it? Because we might need both. We might need to look up the client ID based on a name or look up a name based on a client ID. So which was probably going to be the most common use case in this case? Name to ID? Yeah, you're probably right. I think name to ID is very likely the most common because we're going to be sending two names all the time. We don't often need to translate back from the ID to the name. So it'll be names to IDs like this. So there's a good design decision. So we've decided we're going to map usernames as the key and the socket ID as the value in our object. And this is something, if you're doing WebSocket development, this is something you will do. Absolutely. It'll be an object in memory, remember? This cannot be in a database. This has to be in memory only because these can change in a nanosecond, constantly change on you. So you can't be writing these things all the time. You'll kill your database first off, and it's not necessary. So we've got a database, a memory database of users, much like we did in TinyApp. Really the same thing, where we have our email and our keys. All right. So now we know we're going to go ahead and do that. Let's go ahead and have some way for a user to tell us that they're going to register their name. On the client side, the browser side, they probably logged in. They've done username and passwords. So now the JavaScript and the client says, great, they've logged in. Now let me tell the WebSocket server that I've got Bob on the line here, and we'll connect with Bob as opposed to just a standard connection. So now we can't send information in the connect. There is no way to really send information along with the connect. So we have to send a second message to the server when we're done. So let's go to our browser. So there we go. So we have our connect here. Once we connect, what we'll do then is we're going to send another message to our server, and we're going to say, hey, this person has registered. So I'm going to write here. Once I connect, so inside my connect function, or when I connect, all I have to do is simply send my information saying, I'm here. I have now connected to you. So that's going to be a socket.emit on the client side now. .emit, there we go. It looks exactly the same on the client side, but there's no two because there's only one server. So you just say socket.emit and you send some random event type and you send whatever it is you want to send. Name, for instance. We'll just say name equals Bob for now. Bob gets a bad rap at Lighthouse, I'm sure. The guy never wins at anything, and he's always used as the example. So, okay, and name. I'm going to send the name, and we need to pick out an event name, some random name for our event. We'll call it register. It's good as anything, register. It could be anything. Login is okay, but it kind of implies more than it is. It implies there's some kind of authentication going on, and that's not what's happening here. I'm going to call it register. We're just telling the WebSocket server, hey, this is who I am, or this is who the user is right now. So please keep track of Bob inside memory. So if somebody asks for Bob in another browser, they'll get the right one. They'll get this one. Okay. Now, very likely this is going to be an ID. In reality, this would be an ID, wouldn't it? Like a user ID of some kind, because Bob is probably not a unique name on our system with lots of users. But for now, I'll use Bob. Okay. And we're going to emit the user, register Bob. That's it. So now we have sent to our server the name, in this case, of who it was that connected. Great. Now, let's go to the server and let's catch or listen for that particular event. So we need to, inside our client, we need to listen. So we got disconnect. a custom event. That's going to be a client.on, isn't it? Client.on. And it's going to be the one we invented, which is the register event. And we got some data back. Great. So now we got a register event back. So let's just console log that name. So that'll be the name, because that's what got sent, was the name as our data. I might want to let's call it name. It makes more sense to call it what it is here. Let's console log the name. Great. And then I'm going to add that user to my users database. So it's going to be users bracket name equals client.id. ID. And let's just let's log the users. This is bringing up memories of Tiny App, isn't it? Where we log the URL database every time we did something to see what the heck's going on. Okay, great. So now every time a user has registered, we then add them to our users, add them to our user database, and we're going to dump out the user database, see what happens. And they're all called Bob, which is fine. Okay, so let's go to our server. Let's see if we did this right. Okay, connect. Oh, we have a Bob. Connect. We have another Bob. Uh-oh, we got a problem, right? It's an object. So names have to be unique, don't they? So we simply replaced our old Bob. Even though it's a different browser, we have a new Bob. So, and they just both connected, which is fine, but it wasn't that unique, was it? So I probably should have a way of identifying this. Let me go and add some code to my index.html, because it's getting out of control. Let me add, I'm going to just quickly add a, there, little input, hold on. There, I'm going to put a little input here. There. So I've got a place for them to type their name there in our browser. So they can type Bob and then connect, or type Alice and connect that way. And all I'm going to do inside my index.js is simply now grab that name instead. Okay. So let me grab the name. I need to put a listener on that button, don't I? So I've got the button too. Let me make a little button for my, there's my connect. So now inside my connect, I'm going to grab the name out of that input and then use that to connect with it. So in this case, I'm going to say const name equals, I'm going to grab my there, and what's my input called? It had a class or an ID. ID equals name. So name dot val. Okay. So I'm going to take that name and I'm going to send that name to my connect, which means I'm going to put the name here like this. And then my connect takes a name. So now it knows what name it is. And now it can go ahead and send that name, which is no longer Bob necessarily, to my server. Okay. It's not hard, but you got to keep track of what you're sending. So on the client side, make sure you send a register with the thing you want. And then on the server side, make sure you listen for that same event, that register event, and then handle it. Okay, let's take a look if I've actually done this right. Okay, and let's look at our server log. And then we'll start building a React app as well into some of this. So let's say Bob. Hopefully Bob can connect. Bob connected. Now we have Alice. Alice connected, and we have, great, we've got a third one. Oh, I need another one, hold on. This here, here we go. And Kira. There, great, this is awesome. We really have now the foundations of a great chat app, because now all you need to do is when you want to send a message to somebody, we won't have time to do this today, but I will post the code for that, is we simply send their name along with their message to the server. So we emit to the server an object containing their name and a message. The server goes, oh, who is that? It will look up that name. It will find the socket ID and then send to that user, which is exactly what we want. So now we can use the same thing. If we receive another message, for instance, we had a, there, I'll make it here. Let's say we received the message, client.on, and we call the message type of message is generic. We'll call it a private message. A private message there for our data. And we know that, let's say we received an object, or our browser sent us an object that contained the username and the message. So we'd go const name equals data.name, just to make it obvious what we're doing here, because I want to get into some of the React stuff. And const much equals data.message. Okay, now first thing I need to do is to find out, oh, it's the data.name. I want to find out what is the client ID. So const ID equals. So how am I going to find out the ID of this name? If only I had some kind of table or lookup mechanism to find the client ID for a name. Well, of course I have that. I've got it right here. Users equals users bracket name. Exactly. Yes. There. Well, now I have everything I need for one of these emits, don't I? I can send a message to that ID just like that. It'll be a private as well. Doesn't matter. Private doesn't matter. It can probably have the same name. There. And I can send the message just like this. And yeah, line server. Okay. And there. Oops. Server. Oh, ID admit. Server to ID admit. Admit. Oh, okay. There. Same pattern. Just setting it to the ID that we looked up. And of course now, should this ID change, which I haven't covered yet, we can then still send a message to Bob because we know that we have Bob's ID. One thing we haven't done here is the disconnect, is it? If a user disconnects, we need to unregister them, to take them out of our database, don't we? So one more thing we need to is go ahead and really remove that user from our database if they disconnect. And we can probably make ourselves a I don't know, get user by ID. That sounds familiar, like get users by email. So it's really the same thing, isn't it? We need a function called get user by ID. So make a quick function, won't take long. Get user by ID, and take an ID, and this will be our, do it fast way, for of, and for user, actually be in users. We could use values as well. Okay, for user in users, we're going to say if the user, if the users, that's going to be ID, there, ID and user. If our users bracket ID is our ID, there. This is why we really resist looking stuff up in objects by looping, because it's not easy. But we have no choice. We're then going to return the user. Actually, we'll grow ID. Okay. So now we have our, there's the key. Yeah, the ID. That would be because the key is user. Yeah, so this is great. So this is the user's user. I know it sounds silly, but user, we return the actual name. There, let's call that name. There, okay, great. So now we can now look up the name given an ID, which means we can then use that ID to, or use that name to do other stuff with, right? Huh. Okay, so what we need to do now is handle a disconnect. Okay, so when the user disconnects, right here, we can't send them a message, but we can certainly remove them from our own database, can't we? So we'll do, I'm just going to say const user equals user by ID, our client.id. I'm going to grab the user. And now we know the user, which means we have the key, which means we can remove, if the user, we can remove that user from our database. Use delete. Users, user. There. Or name maybe. Sure. Name instead. Okay. Whew. That's a lot of work. So now we're handling both connect and disconnect, or keeping our users database in sync here. Let's give it a try. Wow. We didn't change anything on the on this client side, did we? So let's take a look. So make sure, oh, disconnect, disconnect, disconnect. Okay. Let's connect. There's Kira. There we go, Kira, Bob. Let's disconnect Bob. And now we'll connect Alice. And we have, go, looking good. Looks like it's working. Just for fun, we're going to console log or dump out our entire, where to go? On connect, we'll dump out our users database. So right here. Okay, one more time. So refresh, refresh, refresh. We should have, hopefully, an empty database. Great. So we'll connect one. We'll connect Kira. We'll connect Bob. We'll connect Alice. Let's disconnect Bob. Great. Let's disconnect. Great. Perfect. So now everything's in sync. Now, as you can tell, it's a pretty short leap to be able to now send messages. You would simply send a message from your front end with a tag saying private. You would emit to, you would get the ID from your database and emit. Great. Okay. Whew, that's a lot of work. Let's quickly go through how this would look in a React app. Okay. This is actually not too hard. So let's close this. We will leave the same server running for now because we use the same one. And let's go ahead and open up a React client for this as well. There. All right. Okay, so this is what it would look like. It's very, very similar. We use a use effect, and all the use effect does, it will simply do the same thing as our code before. It will simply do an IO to slash. Now, since this is a React app in development and it is working in a Webpack environment, we need to do one extra thing. In our package.json, we add the proxy. It was 1801, actually, wasn't it? Yeah, 8001. That's all we have to add, is our proxy. That way, this slash, the Webpack server translates that into this without getting any CORS error. That's all it does. So in this case, I've got my socket, and then when I connect, I should get a connected. Okay, and make sure my server is still running. There's my connect there. There it is. Okay, let's fire up this this other React app and take a look. So one sec while I grab this thing. Never do live shows. I know. npm start. Let's take a look. And of course, my anti-malware is doing its initial scan. But really, everything is the same. You simply, inside your React app, all you do is there. Instead of your document ready, it's the same as this. Everything else is the same. Of course, the accessing socket is by state. You would keep your socket in state. There we go. It's coming up. Come on, it's thinking. It's going to update my browsers. There we go. Okay, great. And let's take a look. All right. Oh, to local 8001. Where am I here? Let's make sure my server is running here too as well. Where's my other server? This is running now. Oh, 8081. Oh, okay, great. Change your app to go on 8081. There we go. And I will have to stop my Webpack because if you change package IO, it doesn't like that. Fortunately, the second time it's starting is pretty fast. So there we go. Okay. And connected. Look at that. So now my React app is doing exactly the same thing. Now, with the React app, you have to add one more little thing. You have to make sure your use effect returns. On the return, it does a socket disconnect because this is a single page app. And this app component can refresh over and over again. So unlike my jQuery, when I navigated away from the page, the browser disconnected for me automatically. In this case, if this component renders, it's going to do this all over again. And I got to be careful. I have to make sure I have to have a socket.disconnect. Yeah, that's right. It goes into waterfall hell. Exactly. Yeah, in the scheduler, you have to disconnect on the return of use effect. Otherwise, just bad things can happen. Seriously, really bad things can happen. Okay. But pretty much everything else is the same inside a React app. Just those two things you have to worry about. Make sure you put inside your package.json, give a proxy, you need that, and all the work goes inside your use effect for your connection, and all your other ons go in here as well. So you do socket.on, and it'll be a notify. There. And there. So it's going to look exactly the same. And this is going to be my data there. And I got a notify. And what did I do in my other app? When I got notify, let's take a look. When I got a notify, I set some text to something. Well, this is a React. So it's even easier than this. I can just put it here. Was it a span? Let's take a look. Where was it? My notify was right there. So let's take that, put that inside a React app. There. And of course, now it's class name equals notify. Okay. And let's put it inside here. React has more rules, doesn't it? Great. So there's and we can't, now this is not jQuery. We can't go ahead and inject it, can we? This is React. It's easier. The whole purpose of React, of Everything that happens in React is what? What's the purpose of any action that takes place? It is to, what should be the end result of every action that happens? Yeah, set some state, change some state, exactly. Everything that happens is just set state. It's so much easier with React. Just set state, every single one of these, set some state and you're done. So we need some state. So const, and we're gonna make some state, we'll call it, notify, why not? And set notify equals use state. I got my funny rig hang happened again. There we go. Actually, I can combine these two. There. Okay. So set my notify. Set notify to the data. That's it. It's much easier in a React. No more worry about what ID it was and change it. Just set some state. And now it goes right there. And now we are in a React, which means it is $ curly brace notify. Let's go back to our app and take a look. Oh, use state. Okay, hold on. Is not iterable. Oh, of course. There we go. And we'll start off as, nothing. Oh, look at that. Connected. Hold on. No $. There. Great, I connected. Awesome. So if I on again, great. And let's make sure that it's working. I'll go to if I refresh the page, it does disconnect and it reconnects. So great. So super simple in React, much more so than jQuery. jQuery is a little more straightforward in that you can see what's happening, but React makes it much easier to work with WebSockets because you just set some state. So if I got a status, for instance, what do you think I do? Well, same thing. Status, I got a status message like this. So let's say I got a stat, I'll maybe set some status. Sure, set status to my data. Sure, I think it's getting the count right now. Later on, you'd probably send an object to your set stat with like 5 users connected, 3 users currently have high score, a bunch of other stuff, right? You get the current status, like the number of players playing, who the top 10 players are, where you are in the list, all these different things you'd get in your status. Okay, and then I'm going to have some status and set status. Use state, and we'll start with 0. Okay, and let's put our players connected. And status, players connected. And status. Okay, back to our app. Equals 2. Anyway, so it's pretty simple to make these in React. All you do is when you receive a message in a React app, you would simply set some state, and that's it. Okay, any questions on WebSockets? They are super fun, really, really fun to play with. And there's not a lot to them. We covered in the first hour, really, the emit, broadcast, or point-to-point, or single ID, and connect, disconnect. That's kind of it. Connect event, disconnect event, emit here, emit there, and then random, just on events for any name you want, notify, status, etc. So really, really fun stuff. If you guys feel like using WebSockets in your final, I'll post the source code for this. I've got a more complete version that actually has some text. You can actually say, send a message to Bob, click send, and Bob will see the message, or it'll send broadcast message. I've got a more of a fully functional web chat app but it's more than we can squeeze into 2 hours for sure. So, okay. All right. Well, thank you for our fun lecture on WebSockets. We get to do 2 of these. I think I had one yesterday, and this one we have today as well. We get to pick something fun, and WebSockets everyone seems to love because it seems to be a very popular thing people do in their finals, and it'd be quite difficult unless you understand how it's working. So if you go ahead and use it, this should make it a bit easier. All right, everyone. Okay, we will see you guys later, and